Geometry, Unit 2, Lesson 1 is called Congruent Parts, Part 1. All right, so our goals today are I can identify corresponding parts from a congruent statement. I can use rigid motions to figure out if figures are congruent, and I can write a congruent statement. So what are corresponding parts? So it says here, for a rigid transformation that takes one figure onto another, a part of the first figure and its image in the second figure are called corresponding parts. We also talk about corresponding parts when we're trying to prove two figures are congruent and set up a correspondence between the parts to see if the parts are congruent. Okay, so in the figure, segment AB corresponds to DE. So kind of think of it like this. If I were to trace this triangle ABC, and if I, this one's real easy because it's just a translation from my rigid motion. You can see here AB and DE correspond, okay? So make sure you say A, B, D, E in that order because you want the corresponding angles to match up. So AB corresponds to DE and angle BCA. So BCA would be right here. So this angle corresponds to that angle right there, EFD. Okay, so there's actually, with triangles, you're going to have three pairs of corresponding angles and three pairs of corresponding sides. So when I look here, and I can just name the angles with one letter. I don't need to use three letters because there's no other angles there at those points. But you can see here, angle B corresponds, and it's actually congruent because it's a rigid motion. So I'll just say it's congruent to angle E. Okay. Angle C is congruent to angle F, and angle A is congruent to angle D. All right, and we know they're congruent because it's rigid motion. If I didn't know they were congruent, corresponds is just that symbol right there. Okay, not a congruent symbol. But since we know that they're congruent, we'll just say congruent. All right, and then the sides would be BC is congruent to EF, and then CA is congruent or corresponds to FD. All right, corresponds doesn't have the equals part. And then AB and DE. All right, so these are my corresponding parts of these two congruent triangles, okay? All right, so what do you notice? What do you wonder? Go ahead, pause the video, try to write down some things. So I noticed that A is the pre-image. How do I know A is the pre-image? Because there are no prime notation marks there. It's just PQRS versus these are prime, so it's probably some sort of transformation to get to there, okay? I notice B looks like a reflection, but I wonder where the line of reflection is. Okay, obviously your line of reflection is going to be right here if I want to reflect A to B. If I wanted to be more accurate with that line of reflection, a better way to do it would be to construct this segment right here. Let me change that, make that solid. Construct that segment, and then I could find the perpendicular bisector. And my picture, it's a little off, it's a little crooked, but you would connect these dots here. And that would be your line of reflection there, okay? And you can see Q goes to Q prime, R goes to R prime, S goes to S prime. So there's my line of reflection if I wanted to find it. All right. Notice C looks like a translation. That one's really easy. I'm just going to translate this down by directed line segment P, P prime, or Q, Q prime, something like that. So your directed line segment would look something like this from P down to P prime. Okay, or you could go, you get same length, same direction, Q to, oh wait, no, that's not going to be a translation. So P to P prime, Q to R. So Q goes down here. S to S prime works, but then R. So it actually looks like a translation, but it is not when we look at the directed line segments. Okay, because again, if you take a look here, let me do this. P to P prime is right there. S to S prime looks good because that goes right there. But then the Q and the R are flip-flopped, okay? So really, I think that they marked it wrong probably. If they wanted to do translation, that would be Q prime. That would be R prime. All right, so the last one. Notice D looks like a rotation of 180 degrees in either direction, but I wonder where the center of rotation is. So kind of like I did before, you could probably find the center of rotation here if I found the midpoint of this. If I connect these and find the midpoint. So somewhere like right around here, that's going to be my center of rotation to swing this all the way around. And you can kind of tell here, if let's say I put this right here at the center, and let's just pick a point here. Let's take, let's go to Q. I extend that out to Q, swing it, rotate it 180, and there it is. It's right there. And you can tell it's a straight line because right there through that center of rotation, Q rotates in that direction. Okay, Q goes right here. Nice rotation, 180 degrees to there. I would do the same thing with P. I would connect this line and rotate P all the way over. Okay. All right, so triangle ABC is congruent to DEF. Now, this is a congruent statement, so it's really important that you write these letters in the right order. So it means A is congruent to D. So here's my A, here's my D. So these angles are going to be congruent. And then you notice that the B is written next, and so is the E. So angle B is going to be congruent to angle E. And then the C is written last, so angle C is congruent to angle F. So there they are. And same thing with sides. If you look at the sides, the AB is going to be congruent to DE. And if you look here, here's AB, here's DE. BC is congruent to EF. And then the last one would be DF and AC. So let me use a different color. Whoops. So here's my DF and here's my AC. So AC, DF, those match up. So there's a couple different rigid motions you could do. Let's see what I put here. I put translate triangle ABC by directed line segment BE. So let me trace this. So by directed line segment BE. So there's my directed line segment. I should have put that with an arrow. There we go. So there we go. We get the B and the E to line up. Rotate A prime, B prime, C prime clockwise until centered at E. You can call it E or you call it B prime, I guess. Until BC, B prime, C prime. That shouldn't be a double prime. That should just be a prime. till B prime, C prime aligns with EF. So I'm going to rotate it. Now it won't let me keep B prime or E as the center, so I'm going to have to rotate it and translate it. And then the last thing would be reflect triangle A double prime, B double prime, C double prime across EF. And there it is. Okay. That should be review. But what you should notice here, though, is after I flip this thing, and again, I apologize for this thing not doing it very nice, but A lines up with D, B and E, C and F, okay, just like we said. All right, draw a triangle. I already did that. Find the midpoint of the longest side. So let me get my compass out. Let's find a perpendicular bisector here. So I'm just going to open it up bigger than halfway. And then I move it over here. And then wherever that line here intersects, that's my midpoint. All right, so I'll mark it right here. And I'll tell you what, I'm going to get rid of all this stuff here. Just, I don't really need it. Whoops, hold on, what did I do? Went back a page. All right, so there we go. Find the midpoint. Rotate your triangle 180 degrees using the midpoint of the longest side as the center of rotation. Okay, so I'm going to rotate this 180 degrees. I'll tell you what, I'm going to do this. I'm going to make the same one, and I'm going to rotate it 180. So you should just use tracing paper, put your pencil right in the middle of it, and rotate it right there. So it should look something like that. I couldn't quite get it to line up perfectly, but just like that, okay? Label the corresponding parts and mark what must be congruent, okay? So obviously here, maybe I should have labeled this thing to start. I'll just use colors here. So there it is, rotate it right at the center, which it did not do. So you can see that this side here rotated all the way over here. This side rotated down here. And then this side in the middle is shared. So I'm going to use the blue and the green in the middle, okay? So there's my corresponding. Oh, you know what? I should have used a different color there. I should just use the third color. So that should have been, sorry, pink, and then another pink because they share the same side, okay? So there's those, and then my corresponding angles. I'll label this one blue, this one blue. I'll label this one in purple, that one in purple, and then this one in red. That's swung all the way down to there, okay? So what type of quadrilateral must it be? I would say a parallelogram. And why? Because these are alternate interior angles. If you were to think of the top and the bottom as two parallel lines, these red ones here are alternate interior. This is my transversal cutting through. Okay, so for A, it was a parallelogram. What is the definition of that quadrilateral type? I guess I need to come up with the other ones. So if I look at these two blue angles, okay, those are alternate interior angles of the other ones, the other parallel lines. So let's take a quick look here. If these are my parallel lines right here, the blues are alternate interior because they're on the interior of the parallel lines, alternate sides of this transversal here. So we could say that these are parallel as well. So what is the definition of that quadrilateral type? Two sets of parallel sides. What must the quadrilateral you have? Why must the quadrilateral you have fit the definition? We have two pairs of congruent alternate interior angles. Okay. Another one here. Let's make a congruent statement. So I'm going to use rigid motion here. So I'm going to trace this as best I can. Let me start over on that. So figure one, let's trace this one. All right, so looks like I'm probably going to need to do a reflection here and a rotation or something. So let's see if I can. Yeah, it's still not right. So I'm probably going to need to do a reflection. I'm going to reflect it to start. And then I can rotate it. Wait, I guess I didn't really need to do that. Let me go back. Oh, I don't need to reflect it. There we go. All right, so there it is. So you can see T goes with H, S goes with G. Hard to tell because the letters got all turned upside down. This was the U. U goes with I, and V with J. So we could say VTSU is congruent to V was with J. T goes with H over here. S with G. And U corresponds to I. All right, so there's my congruent statement using rigid motion. So that one I didn't have to reflect. It was just to translate and rotate. All right, write down your reason why corresponding parts of congruent figures must be congruent. So this is actually what we call CPCTC. Corresponding parts of congruent figures. Wait, corresponding parts of congruent figures. Corresponding parts of congruent figure, CPC. Corresponding parts of congruent figures, congruent, CPC. CPC, it's CPCTC. Oh, it's triangles for triangles. That's what it is. I knew something was wrong. So we normally say CPCTC, corresponding parts of congruent triangles are congruent, but it's actually, we're not saying just triangles, we're saying figures. So CPCFC, I guess, but we don't really use that. When eventually we do triangle proofs, this is what we're going to use. CPCTC. I knew something was wrong. I'm like, CPCFC doesn't sound right. So, yeah, it's because it's triangles, but we normally do triangle proofs a little bit later. But anyways, so why must they be congruent? The answer is we are using rigid motions. So the corresponding parts must be congruent because angles and side lengths do not change with rigid motion. Okay. So back to our goals. I can identify corresponding parts from a congruent statement. I can use rigid transformations to figure out if figures are congruent, and I can write a congruent statement. Okay. So triangle A prime, B prime, C prime is a reflection of triangle ABC across line BC. Prove that ray BC is the angle bisector of angle A prime. So A prime is this angle right here, and we want to know that this is the bisector, angle bisector. So here's what I put for my reason. I put rigid motions preserve distance and angles. So angle ABC is going to be congruent to angle A prime, B prime, C prime, because reflections preserve angles. So therefore, we can conclude that BC is the angle bisector because of the definition. So I might want to add that in here. So BC is the angle bisector of angle AB A prime because of the definition of an angle bisector. Okay, so there you go. That is this lesson. Hope you enjoyed it, and we'll see you next time. Thanks for watching.